working on something, wants to share kind of maybe some roadblocks or some questions you might have. And if you ever want to share some code, head over to our Discord, and that's probably the best place to share some code.
So what we were going to do today was the super app tutorial, the tutorial. So, you know, in the docs, there's the tutorial and then there's docs. And so as part of the main tutorial, it takes about an hour to go through the whole thing. There's a section just on super apps where we go through the Holy Grail contract. And so probably the base for today is just going to be kind of coming back to the Holy Grail contract and referencing it. And so super apps, and then if you scroll down a little bit, there's a link. You can watch the whole video, which you don't need to because you're here now. You basically get some tokens from the app. So you just go to app.superfluid.finance, connect your wallet, and then you click this remix link right here. And what this remix link does is it loads up all the contracts in your browser and imports all the dependencies that you need and sets you up with a scaffold super app that you can start playing with. And so today, when we're talking to you guys and answering questions, this is like what I'll be referring to. So if you want to go to docs.superfluid.finance, super apps, and then click this remix link, and then that'll give you a good reference for what we're talking about. And this is like a fresh virtual machine, so everything here is like for the first time. Yeah, we'll give Remix some analytics, sure. And then tradable cash flow is our main contract that's handling NFT stuff, and then redirect all is our super app logic, and all our nerdy technical stuff is in here for making a super app. So if you've got questions, throw them in the chat. Otherwise, I'm just gonna keep marching on with this. I mean, even you can raise your hand too. Raise your hand if you want to ask out loud, and we'll unmute you. Hooks. Okay, we got a question about hooks. So your super app is like a smart accountant, right? And they are monitoring what's happening with all your streams, and they can react to certain things that happen. So, and not just streams, for IDAs as well. So any of the agreement classes, constant flows, or IDAs, our super apps can respond to changes. And hopefully that's what you mean by hooks, because there's also ERC 777 hooks as well, but I'm just going to assume that you're referring to super app hooks. Essentially, we have the ability to trigger certain logic when agreements are created that involve our super app. So for instance, in the redirect, in the Holy Grail contract, anytime a stream of DAI is opened up and sent to the super app, to the NFT contract, we are going to catch that and then run our own logic that says, okay, now from the super app, I want to either make a new stream or update my current outgoing stream to somebody else, right? So think of like, if you just send somebody some money, right? And it's just like a single transaction, they receive it, they get it on Venmo, it pings them, whatever, right? So like that ping that goes off is your hook, right? It says, okay, after I receive the money, what do? Oh, I give the person a notification, right? And in our super app, we can do anything we want that a smart contract can do. So anytime a stream is opened up to our super app, we can trigger a logic, and these are we can call these hooks. What else? What's another word for it, Fran?
Callbacks, I guess.
Callbacks.
That's the word we usually use.
Callbacks is like the official term for it, yeah. So in the Holy Grail example, and let me make this a little bigger here. We have 3 callbacks. We have after agreement created, after agreement updated, and after agreement terminated. And for most of what you're doing, you can use, there's like before and after. So you could put before agreement created or after agreement created. And you could probably stick to using after agreement created for now. So that kind of cuts down the number of things you have to worry about. And then it's just create, update, and delete, right? Create, update, terminate. So in this example, we're just saying when any of these three things happen, we're gonna call update outflow, which means when anyone changes their stream to the super app or stops a stream or anything like that, we can respond to that and update how many tokens are flowing out of it. So yeah, that's the gist of hooks. And then what we're doing is after we, within the hook, we're using context to pass data about what's actually happening to the stream. So that way we can.
Yeah, so the next question is, when we hit the cancel stream on Superfluid dashboard, is after agreement terminated hook called? Yes. If the person if the address that is receiving your stream has first registered as an app. So Pat, if you go up to the constructor so we can show, basically when you create a super app, when you deploy it, you register it to the Superfluid host. And when you register it, you're telling the host, hey, this address is an app, right? So if somebody sends a stream to this address, you have to check if I have callbacks and call those callbacks. Right. So then when you close the stream, it'll also call the callback. And that's your way to update your internal accounting or update, your internal logic.
Yeah. Yeah. It's kind of like the host is like the central hub for everything. Right. And then your super app is like your little accountant guy out there, managing your money, figuring out where everything should go. And then like Fran's saying, if he's registered with the host, the hub, and the hub's like, hey, a flow was opened. Like, here's the details about it. Go do something. When a stream is set to a 0 flow rate, does that automatically close it and trigger the callback? Okay, so again here, so the callbacks, right? The callbacks are app specific. So if your stream doesn't involve a specific super app, then it's not going to execute the callback, right? So if I'm not sending funds, if I'm not streaming funds to the Holy Grail contract that I'm deploying, this one right here, if I'm not sending it to that, and I'm just sending to, Alice somewhere else, like this is not gonna get triggered, this callback. So you have to remember that the callbacks are only relevant to the people who are doing the streaming. So that's the first thing. And then if you set it to a 0 flow rate, does that automatically close it? Okay, so I think this is a good question because it raises something that I'm actually not sure about. So Fran, so if we set a flow rate to 0 versus delete flow, is there a difference?
If you set it, okay, so it depends, right? And this is where it gets a bit tricky. If you're using the JavaScript SDK and you do user.flow flow rate 0, then it will, what's actually happening is it's calling delete flow. If you try and do update flow 0, it's actually going to just revert. It's not going to work. Okay. So you have to call delete flow. But if you're using the JavaScript SDK, it's very nice and simple. You just put 0 and it deletes it for you. So that's kind of just to make it a bit easier on the front end.
Yeah, so does it automatically close the stream if we set the flow rate to 0? The answer is yes. If you're using the JS SDK, it's going to automatically close it. And does it trigger the callback? Well, if it involves the super app, then yes, in this Holy Grail example, because we have the callback here after agreement terminated. If we didn't have this, then it wouldn't get triggered. So agreement terminated occurs when we stop the flow. Is there an agreement terminated callback for IDAs, for instant distributions?
Yes, if you're using the instant distributions, you can still use the callbacks. So they work exactly the same way when you create updates or terminate the flows, which is the reason, actually, one of the arguments, if you look at the callback, is agreement class, right? So the agreement class is going to tell you what kind of agreement it is, because with Superfluid, you have more than one. The basic one is streaming, right? So we call it the constant flow agreement, or CFA. But there are also others. So if you want to make sure that your callbacks are only called when somebody sends a stream, then you have to check that, which is what, if you see, Pat, if you go to only expected on the update, on the second callback, there's something called only expected. Yeah, so that's basically checking, is the user sending a stream, and are they sending a stream in the right token? Right? Because if you don't check, the user could send any token or any agreement, and they would still trigger the callback. So you have to check these things. But if you use the boilerplates from our examples, it should be quite easy to follow those patterns. You might notice that in the after agreement terminated, instead of using a modifier like in the previous one, we are using an if block. Now, this is because, and this is a very important thing with super apps, you can't revert in a termination callback. So instead of reverting, so instead of using a modifier that has a require inside, instead of doing that, we use an if block, so that instead of terminating, we simply exit the app without reverting. Now, this is important.
What happens if we revert?
Very bad things happen, so don't do it. Your app will basically be jailed. So this is it basically means that your app is not usable anymore. Now, this sounds very harsh, right? But the reason for this is actually to protect the users. So if let's imagine I create a malicious app, right, that takes your funds, like it says it's going to do something, but actually it just takes the money. And Pat is sending me a stream, but I built my app so that if he tries to close it, the callback will stop him and won't let him close it, right? Then I could basically keep that app stealing his money forever. Now, this is obviously something we have to avoid, right? The user has to always be able to close their stream if they want to. But because of how Solidity is built, there's no way to tell if it's reverting for a good reason or a bad reason, which is why you simply can't revert. So whatever you build, if you're using super apps, be very careful not to use reverts or requires in the agreement terminated callback, because it might get your app jailed. You can usually find all the cases where it would happen in tests, but just be extra careful. So Vivav was asking on YouTube if we can stream NFTs. So we can't stream NFTs because NFTs are one thing, right? You can't really break them. If you fractionalize them, then you could stream them. But what this contract actually does is slightly different. So what it does is it tokenizes as an NFT a stream, so that you can basically transfer an NFT, and by doing that, you kind of send the stream to someone new. So it's a slightly different use case, but yeah, still using NFTs. So Harpal is asking, NetFlow can return negative flow rate. Can GetFlow return negative values? No. So GetFlow will always return a positive value because it's always from the point of view of the sender. But NetFlow might return a negative value because it could be from the point of view of the sender again. So if you're sending a stream, then your NetFlow is negative. But if you ask the chain to get the data from that flow, it will return a positive value. So that's a good catch. It might be a bit confusing. So the net flow is the difference between all your outgoing streams and all your incoming streams. So if if I'm sending Pat $100 and he's sending me 50 back, my net flow will be minus 50 because it's minus 100 plus 50. Does that make sense, Harpal? Perfect. All right. Is it possible Is it possible to lock an address that's receiving a stream till the stream is completed?
This is a good one. I think there's a lot of questions about stuff like this. Like everyone, okay, so there's this idea that we want to ensure that the stream is completed, right? Whether that's like, I am sending you 1,000 DAI a month and we want to like shut it off after a month and maybe make sure that, you know, the stream is actually done, or I'm receiving it, you know, I'm receiving 1,000 DAI, and like at some point I want to just be like, why don't you just transfer the 1,000 DAI and not not use a stream, right? If that's your use case. But I'm trying to think of examples where this is important, right? Like we want to be transferring money over time, and maybe we only want to be able to stop it if certain things happen, right? So like if maybe this is like an escrow that we're using, right? And then there's some disagreement that happens, then we could stop it. But otherwise, the money is going to continue flowing. Can you think of any other examples, or maybe whoever asked the question can post the example that they're.
Yeah, like Light is saying, you can't revert. So yeah, I mean, one case where it's very important to have to make sure somebody sends all the money is if you're doing vesting, right? So if you have some investors who bought your token and you want to vest it to them, then you want to make sure that they vest the full amount, because otherwise they could break the contract. Now, the only way to do that is to basically turn on the car, put a brick on the accelerator, and throw away the keys, right? So deploy a contract, put the money in, open a stream in the constructor, and don't have a function to close the stream.
Yeah.
Right. So if you do that, basically when you deploy the contract, it will start the stream and then it will never stop. However, it might stop because the protocol allows the receiver to close the stream. So if you do this and you, like I said, throw away the keys, the stream will keep going. But if the receiver closes the stream, then the money is in there and there's nothing you can do. So it's a bit tricky. You have to kind of think of the protocol as something that it's not opinionated, right? It's built to allow you to build other things on top. So if you want to stop someone from creating a stream that they can't stop, you have to get creative, because the protocol will always allow everybody to stop their streams.
Which is good, right? Like if a DAO or something starts, like some contract starts streaming me all the funds and I'm like, whoa, like I'm not supposed to be getting, you know, then I should be able to stop it.
Yeah, I mean, it gives more control, right? The protocol is trying to give control to the users of their payments, right? And the receiver is also receiving payments. One thing you can do with super apps, actually, this super app, for example, because it has that callback called only expected, if you try to send a token it doesn't want, it will not accept it. The call will revert. So it's like, I don't want your, Bitcoin. I only want dollars, right? You can build that into the contract, which is something I think you couldn't really do with ERC20s, for example. Like there's contracts that get filled with, Vitalik's address is full of Shiba tokens, right? But he couldn't say no. This app can say no because consent is very important. Pat, do you want to go? Oh, let's see. So Harpa is asking, get flow token sender receiver equals 10. So shouldn't get flow token receiver sender minus 10? No. Okay, that's another good point. Okay, you're smart. No, because there can only be one stream between a sender and the receiver. Okay, so if I open a stream towards Patrick, and then I want to send him more money, I have to update that stream. I can't have two parallel ones. But Patrick can open a stream towards me. So basically, sender and receiver are different. So if I am sending him money, it doesn't mean he can't send me money. So Light, to answer your question, basically, if I'm sending money to Patrick and you call get flow, you will get 10. But if you call it with the receiver and sender inverted, you won't get anything because he is not sending me a flow. So you have to get the sender and receiver right when you query get flow.
What happens if I am sending some back to you?
If you are sending me money back, then when you call get flow, you will get that amount, and our net flows will net. So netting is this mechanism where your incoming and outgoing balances are, well, flows are kind of cross netted. So basically, if I'm sending Patrick $10 a second and he's sending me $10 back, we both have a net flow of 0. And this is actually a very useful mechanic to use in your apps because, for example, if you're building an order book, you can actually build an order book where I'm sending money to an app and the app is sending me all the money back because my bid, for example, in an auction or in a market, my bid is not being taken, right? But my bid is still there. So if I'm sending money to the app is sending the money back. It means the app can stop sending me money back at any point in time. And when the app stops sending me money back, it's as if I had started sending money to the app. So this is the only way as an app you can kind of have a user decide when a user pays you. Otherwise, this decision is always in the hands of the user. But if you use this trick, you can kind of manipulate that a bit, but only to the extent that the user has first sent you a stream. Okay, so Adebayo is asking, is Superfluid available on any L2? So at the moment, Superfluid is available on a Polygon and on XDAI. We are working very hard on our next deployment, which will be on Rollup, coming very soon. We're working on their testnet. Everything seems fine. So hopefully we'll be able to have that very soon. And we're very interested in other L2s. So if that's something you have experience with and want to help us deploy it, come to our Discord and we can talk about maybe collaborating on that. Ultimately, we think Superfluid should be deployed on all L2s. It's just a lot of work, but we'll get there. So I'm checking if there's any questions on YouTube. Okay, it looks like a team is forming on YouTube. That's interesting in the chat. All right. Okay, Praful Sahu, what happens when a distribute function is called on an IDA, but there are no subscribers to that IDA? Wow. Okay, I must say I'm not sure what happens. That's a good one. Okay, if I know meow, I'm gonna guess that it probably reverts, but I'm not sure. I'm gonna go and double check that for you.
Gabby?
Yeah.
Hello?
Yeah. I can hear you.
Yeah, so it will revert, I think. Yeah, so it's a 0 units, you divide by 0 to revert. Yeah.
Okay, that's good.
Can't divide by 0.
All right, thanks, Meow. We didn't know you were in the chat. Thanks for saving us. Yeah. So it will revert if you don't have any outstanding units. Yeah. Actually, wait, but that's slightly wrong, actually, that answer, because Praful was asking if there are no subscribers.
Oh, yeah.
Right, which is not the same. So with an IDA, you can actually distribute units, but maybe the person you distributed units to hasn't subscribed. So that's possible, right? And that will work. It will still distribute. The user has to approve the subscription before they start receiving the money in their wallet. Exactly. So if you don't subscribe, you can claim, like Light is saying in the chat. So Pat, we have someone who's read all of your docs. Light has read every single piece of the docs website. He's really thorough. And yeah, so you can everything, you see. So you can always claim it afterwards. So you either subscribe to the shares or you can claim them. So if you claim them, it's very similar to a yield farming app or something like that, where you can withdraw the money. But if you subscribe, then you get the money straight into your wallet with no further transactions. So depending on what app you're building, it's better if you can get your users to subscribe. If there,
Hi. Can I ask a question? I'm Praful.
Sure, go ahead.
Yeah. So actually, my question was like, if I do understand this part that for the money to go to a subscriber, they have to approve it. But my question is, suppose an idea is created, it's a new idea, and there are no subscribers. Again, basically, I have not added any subscribers to that idea. And if somebody tries to send, send the money to that, and I call a distribute function on that idea, what happens?
So nobody has gotten shares yet, correct?
Yeah, correct.
That's the case that Meow was mentioning, where in that case it would try to divide by 0 because there's no shares, and so it would revert.
Okay, got it. Okay, so that's why I think so. I'm trying to do that on my contract through MetaMask. I have written another contract in which an IDA is called to distribute that, the amount that is received. But yeah, on MetaMask, I'm getting an error when I don't have any subscribers. So that must be the case.
Yeah.
Got it. Thanks. That clears it up. Thank you.
Yeah, that makes sense. Okay, so Michael Santori is asking, what is the inspiration or use cases behind the super tokens ERC777 callbacks functionality? So the ERC777 is a more advanced token standard than the ERC20. It was created later. It has some this hook functionality is very interesting because it enables you to do things without needing a token approval. Now, if you've ever used DeFi apps, even Uniswap, right, you'll see that you always have to do 2 transactions. The first transaction, you are approving the contract to use your tokens. And the second transaction, you're actually doing the thing you wanted to do, right? Now, because there's this approval step, there's actually been a lot of hacks because if the moment you approve a contract to use your tokens, that could happen maliciously, right? Somebody could use your tokens for something that you didn't really expect, right? Because you just approved them. You don't actually know what they'll use it for. Now, if you're using something like Uniswap, which is immutable, it's audited a million times, there's no governance, there's nothing you have to trust. Sure, it's fine. You can approve and then it will work. But you still have to do 2 transactions, which is annoying. But if you're approving a contract which might be changed in the future, then you're facing a risk when you approve them.
Yeah, the difference is like if you go to a website and you give them your credit card number and stuff, or you give them your bank account, really. Like sometimes, you have to do direct deposit and stuff. It's like giving them your bank account number and being like, I hope they don't charge me for shit later, versus like just handing them cash. Like if you're standing there and you just hand them cash, they can't take more money from you, right? If something went wrong. Let's say they just made an honest mistake, right? If they have your bank account information, they can keep charging you because you made that approval in the contract to spend your tokens. You're allowing them to spend your tokens. But with the ERC 777, it's more like they can only do stuff when I hand them cash. And if like after that, they can do that, but they can't take more money out of my wallet, basically.
Yeah, it's in jargon, this is a push payment rather than a pull payment, which is similar to the way Superfluid streams work, right? You can, nobody can pull money from your account, but you can push it to the account. And when you push it, you can execute logic. So that's kind of the inspiration. So if you talk about use cases, it's basically anything you've ever done in DeFi, but without needing to first approve the contract. So you have a better UX, you only have 1 transaction, and you can kind of do things in a simpler way, basically. So
we should add, I just thought about this. Why for our super token upgrade and downgrades, do we support 777 to perform an upgrade, right? We should.
If you come with a if you come with a 777 token, yeah, we should, but nobody uses them, so we never did that.
Nobody uses them yet.
Yeah. But if you create a custom wrapper, you can always add that. So that's a good point. If you're gonna wrap an ERC 777 token, then it would be very cool to add a wrapper on the hook as well. That's a good idea.
And there's a bounty for this, right?
There is a bounty for this. Yes, it's one of the bounties we put out for this hackathon. Okay, so let's see. We have another question here. Is it possible to convert super tokens on chain? The scenario would be the user subscribes to the super app. The super app converts the X tokens to standard ERC20s, let's say USDC, and sends them to another protocol, for example, Aave. So no, yes, but no. Okay, you can do it for sure because you're building a contract, right? Contracts can do everything, but you can't do it in a stream. So what you're going to have to do is build some sort of system which takes in a stream of USDCX and then takes chunks of that and throws them into Aave, basically, because Aave simply can't accept them. And there's no way to stream normal USDC. Otherwise, we would do that. So the only way to do this is create a super app which will receive the money basically every now and then, say every hour or every minute, we'll downgrade it, deposit it into Aave, and upgrade the internal accounting. Nice. Thank you, Michael. That sounds very interesting. Maybe reach out afterwards and tell us more about your hack. And by the way, if anybody in here is still looking for a team, there are a few people who were asking me earlier. So feel free to let us know and kind of what kind of person you're looking for, and we might be able to help you find someone. But yeah,
this
DeFi.
hackathon is crazy. So many people are building right now. Yeah,
it's great. It's great to see so many people interested. Okay, so Mr. Clean is asking, can we set up an ERC721 and call the Superfluid IDA from that ERC721? Example, a user mints an NFT on Polygon, then that NFT uses an IDA to distribute tokens when someone requests a payout based on some business logic. Yes, yeah, absolutely. This sounds really interesting. So you could put money in an NFT and then transfer it out. Yes, you can absolutely do that. So you could have, so actually when you register an IDA, when you create an IDA as the payer, you have to record what's called an index ID. And that could be the same as your NFT ID. So then you can easily subscribe to that. I'm interested, what's the use case you're thinking about? By the way, guys, feel free to unmute yourselves and talk.
We have, don't forget about the examples folder. I think we have an example that kind of says something like this, maybe?
Yeah, it's a bit similar.
If you go down to examples and then official examples, there's a link here. Basically, it's just in the repo, there's an examples folder. And I think it's the rewards distribution auction that might be the most helpful.
Yeah, I think the reward distribution token is the only example we have with an IDA. So that would be the place to start if you want to use an IDA. The IDA, for those who haven't looked through our docs yet, it's basically a contract which allows you, it's an agreement that allows you to distribute super tokens to any number of receivers. So if you have 1 million receivers, you can send funds to all of them at a fixed gas cost. Now, this is very important if you want to build a scalable app which distributes funds, because obviously if you wanted to use transfers, you would have to make 1 million transactions. But using the IDA, it's one transaction with a fixed gas cost, regardless of how many receivers you have. So you can build these very wide distributions to many users without even having to worry about how many receivers you will have, right? Yeah. If you're building a normal app, sure, you can handle it through transfers, but at some point you hit the gas limit. And then if you didn't plan your app properly, you won't be able to process all the transfers.
And there's like the naming there, right? Instant distribution. It's kind of like a front loading some of the effort of assigning how many tokens people should get ahead of time. So that way, when it comes time to actually distribute the tokens, it just happens, you know, all in one go. So you're kind of like doing some of this pre-work ahead of time so that the distribution can be instant and painless. But that said, is that like, if you have to give a bunch of people shares, right? You know, you might be saying, okay, well, I got to do a bunch of transactions, right, to give everyone shares. But you can actually batch call those, which is another feature that there's actually a bounty. There's a bounty for that, right? Just
No, there's no bounty for batch calls.
no bounty. But you're welcome
But yeah.
to use it because it's nice. You can give shares and do a bunch of things all in one transaction, super apps and token stuff and all that good stuff.
Yeah. So one of the design goals when we started designing Superfluid as a protocol for developers, right, was to enable you to do as much as possible in one transaction. So when you use ERC-777 hooks, you can execute logic with one transaction, right? You don't have to approve the token first. When you open a stream, you can have logic that happens when you open the stream, so you don't have to do things first. And we tried to build this into everything we did, because ultimately, as a user, you really want to only have to sign once. Like signing 2 transactions, it's not just the fact that you're doing it twice. It's the fact that between the first and the second transaction, there could be a period of time. Right? So if you're a user, you sign a transaction, then you have to wait for that transaction to be confirmed until you can sign the second one. It's very annoying. So everything in Superfluid you can do with one transaction. So we have a functionality called the batch call. Pat maybe showed the docs on that one. The batch call enables you to batch, I think, up to say 50 operations into one. So if you want to open 50 streams, you can do that in one transaction. If you want to make a transfer and then a stream, you can do that in one transaction. And this is very useful if, for example, you're transferring an NFT, but you also need a stream, right? So for example, maybe I have an NFT, but I have to stream money to it and then pay for it, and then I can get it. You can do all of that in one transaction using the batch call functionality. We have an SDK for it. You can also, interact directly with the contracts. It's quite easy to use, and it's super powerful because you've actually never been able to do this much as a user without interfacing with a contract. So by using this, you can automate all sorts of stuff.
Yeah, like, I mean, I remember, what was it, like East Waterloo, maybe. I mean, it was ETH Boston, September 2019, I think. Everyone was talking about this kind of stuff and doing contract instantiation for a single transaction using Create2 and like all this. I mean, dude, it's like you can go off the deep end with the Solidity stuff for like how to batch, like, discrete transactions together, and you can spend a ton of engineering time just trying to figure out how to make that work. Or you can just use the batch call feature and you don't have to write any contracts or anything.
Yeah, just to take a question from YouTube, Vaibhav is asking, can we change receivers midstream? The use case is donating money to organizations in some pattern. So you can't really. So when if I open a stream to Patrick, I can't change that stream to go to Meow. What I would have to do is close the stream to Patrick and open a new stream to Meow. And that can only be done by the sender. So if you want to build something more automated, then you would have to use something like the contract that Patrick was showing. So Pat, if you open the remix again, so this contract basically takes a lot of streams and then sends them to one person. And that basically, because it consolidates them into a contract and then sends the stream out, you are able, as the contract owner, to actually define where that final stream goes to. So it's, once the sender starts a stream, can there be a functionality where the sender can add upper limit to the token so that all of its tokens are not streamed? No. So a stream is very simple. A stream is simply two pieces of information. Well, three: the sender, the receiver, and the flow rate. That's it. There is no end date. There is no maximum amount. There's nothing else at the protocol level. So the protocol is trying to keep things simple, because keeping things simple at the protocol level makes the protocol more scalable. Now, if you want to add things like a maximum amount, an upper limit, an end date, you can do all these things, but you have to do them a level up. So by building an app or building a contract or somehow automating on the client side. But the protocol itself is trying to be as simple as possible. So streams are either on or off. They can't be late or expired or run out. They're either on or off. Very simple. Which means that when you're building an app, you can reason with it, right? Because the stream is either on or off. You don't have to kind of find out too much. So Harpal was asking, if we revert in a hook, like create or update, will it revert the transaction that invoked the hook? Yes. So if it reverts in the create or update, then basically your transaction will revert and it won't happen. So the stream won't happen, basically. No, actually, that's wrong. So if you revert and create, the stream won't happen. If you revert in update, the stream will stay the same as it was before. Pat, Harpal is asking, when we use batch call, do we get the status of individual transactions?
Well, depends on what you mean by the status of individual
Can I speak?
Yes.
Yeah. So what I mean by that is, like, let's say I have a single button which takes your die, converts it to die X and starts a stream. So I want to create an interface where it shows that right now I am converting your die to die X and show a loading spinner. And then when that is done, I want to show a green tick, and then I want to show that now your die X are going to be streamed to the app, and there will be like a loading spinner, something like that.
Right. Yes. I mean, it happens all at the same time.
Right. So I can have a batch
it's-
call, but I want to give the user information, right? Like what is happening right now.
You can totally make some UI thing that shows it, but when that transaction is processed, it all happens in the same block. There's no time. Like, it's instantaneous. It's either the transaction's processing or it's been processed. There's not like a I don't know what the word for it is.
Yeah, there's no
queue.
delay. There's no queue.
Yeah.
Yeah, exactly.
Right.
So,
and if any of the batch call transaction reverts, all the transactions revert, right? In the entire batch.
I believe so.
Like even if I created my die to die X and I started the stream, but because my balance was low, the die were never converted to die X also, even though that step was cleared, but it reverted back.
I believe so. Yes. Yeah. Do you want to maybe clarify that? We're gonna say yes for now.
Okay, thanks.
Actually, I'm not so sure I understood the question. Sorry.
so the question, Meow, is if you do a batch call with, say, 50 streams, streams would be different. If you do a batch call with a lot of transfers, and at some point you run out of money, will it fail? Will the whole thing fail?
Yeah, actually, a current version would require everything to success. You can think of in JavaScript like promise.or. So it's not like one can fail. Actually, everything should fail. Everything should succeed. If anyone fail, you kind of just wasted the gas and everything revert. But if there's a request that something else need to be done, we could implement more feature. It's the protocol is still in developing. This is something we can think about. So kind of extension or something if necessary. But currently, yeah, it will fail.
There you go. So Light,
Yeah,
when you become more advanced at Solidity, you can come and help us implement that in a different way.
So to answer your question, if you upgrading DAI to DAI X and then opening a stream, and for some reason you can't open the stream, then yes, your DAI X will actually never be upgraded. So you'll keep your DAI. Nothing will happen, basically.
Got it. Okay. Cool.
Yeah, or use another word. You can call it a atomic transaction in a way that So it's if one action fails, everything gets reverted.
Got it. Got it. Okay.
Light, do you want to tell us what you're building? Because I think your idea is pretty cool.
I'm actually building a video streaming platform where for the amount of time you watch, your streams are on. So I'm the guy who is pinging you again and again for the end of protocol thing. If you remember, yesterday I told you that I have achieved the functionality where you start a flow and you receive the key for the lock. But the problem is the user can go to the Superfluid dashboard and cancel the stream, but the key does not get returned back to the protocol, or you can say the key does not get expired. So that's where I'm stuck right now.
Oh, sounds like you need the after agreement terminated callback.
Yeah, but I'm not sure where the transaction is successing. Like it shows that the transaction succeeded, but there is something written in yellow color, like there were some rewards in this, like you said, terminated cannot be rewarded, right? But there are some errors in there. I'm not sure where the error is right now. So yeah, that's where I'm stuck.
Right. Yeah.
So the
always
terminator
tricky.
always succeeds, but there is some error somewhere, I'm not sure where, that the key is not being expired, so that the guy cannot view the content anymore.
I think it might be because you're somehow terminating incorrectly. But yeah, we're happy to look at the code. If you want to share it on Discord, we can have a look and try and debug that for you if you want.
Sure.
There's the Hangout chat where you can share that and we can have a look.
Sure.
But yeah, what's everybody else building? I'd love to kind of hear about what kind of ideas are being developed at the moment, and if there's anything that we can, maybe try and help you understand if it makes sense, if how you would build it or anything like that. If anybody has any questions, feel free to take the floor.
Hi there. This is Jenny Vora. So I actually messaged in Discord regarding that Superfluid app that I was planning to build a video streaming app, like Light said, where a user can get some tokens and start streaming that content. But that was already used in previous hackathons, right? So I pivoted to something called as shopping application, like where even if you don't have enough tokens to buy an item, but you can still start the stream, and once the stream is completed by the upper limit, the seller will receive the notification and it can start with the delivery. So I'm sort of pivoting on that, on how to work on it.
Interesting. It's very cool. So it's like a checkout where you buy now and pay in a stream.
Yes. Yeah. We can say simple checkout.
That's very cool.
But I have a lot of things to learn from you guys.
Yeah, no, but I think, look, that's a very powerful thing. We've been wanting to see a good checkout for a long time, and it's good because you don't really have to use Solidity, right? You can just work on the front end and build, maybe use the graph to get some of the data, but you don't really need to ever touch the smart contracts, which means it should be easier to develop. You'll find less problems, and you can just focus on the front end.
Okay. Thank you. But I was really worried about that upper limit part. That if the item is of $100, then
Yeah.
the streaming should stop. So maybe I will build a super app for that. I have to figure that out actually.
Right. Well, a contract could help with that. You could build a contract which can kind of check how much money has been sent, but you will always need someone to check. Like the contract itself can't, it can't just do things, right? Somebody has to always trigger the actions. But yeah, there's some ways you can do that.
Yeah, there's a couple of solutions. One is Gelato Finance, or not Gelato Finance, Gelato, I think it's just called. And that can trigger certain things to happen on chain. So you could set a date, right? And then trigger some function to be called at a specific time. That might be one solution.
Okay. Thank you.
There needs to be a standard for contract that can listen like WebSockets. Yeah, that would be very helpful. The problem is somebody has to pay because everything is metered on the blockchain, right? Every action is metered, so somebody always has to pay, which is always a bit of a problem. But hopefully somebody will figure out that that kind of thing in the future. All right. Anyone else that wants to tell us what they're working on? I think maybe, I don't know. Trying to recognize people here from Discord, but you all use very different names on Discord, so I can't recognize you.
Maybe I can share our idea.
Yeah, go for it.
Okay, so we are trying to build, let's say, a loan repayment platform. So, for example, when users take loans at Aave, so they borrow some money there. Let's say they put ETH and take out USDC, and we want to make a platform where they can come in and say, okay, I want to repay my loan, let's say 10 USD or some Ether per month, you know, like in multiple installments. And we want to use Superfluid for that. And basically, I thought we could use super apps where we get the subscriptions from the users, and we do the conversion there and send the borrowed funds to Aave or any other protocol, let's say Compound. But so basically, there is that challenge with the super app. I think we can figure that out, but we were also struggling with the user onboarding experience because they need to convert to super tokens, right?
Yeah, yes. So I feel you. I understand where you're coming from in the sense that it's something we struggle with all the time. But ultimately, you know, if we wanted to make streaming happen, this is the only way. We needed our own token standard. So it's what we had to do. I think it's not going to be so much of a problem in the future because we are starting to see people, for example, pay salaries using Superfluid. So if you start receiving your your income in streams, then using streams to repay your loan makes a lot of sense, right? You don't actually have to upgrade in that case. So I wouldn't worry too much about that for now. And I mean, after all, you're just building a hackathon project, right? We can always solve that problem at a later stage. But we're also potentially working with some people who will create tokens that don't need to be converted. So not all tokens need to be converted. If you issue a token directly on Superfluid, then you don't actually need to convert them to a super token because they are a super token. So I think in the future that problem will wane away. So I wouldn't worry too much about it. And apart from that, I think it's a great use case. Like it's exactly the way we repay for a mortgage, right? You don't repay in a lump sum, you repay over time. So I think it makes a ton of sense.
Yes, thank you. We were just trying to see if we can like maybe solve that problem somehow. I mean, it's not a huge problem, I guess. But yeah, and also I wanted to ask you maybe for in the future, do you plan some like native integrations with Aave or some other protocols?
So we were talking today with one protocol, which is not Aave, a different protocol for yield, and it's definitely something that that they are interested in, because I think a lot of people in our space are very excited about things like salaries, right? We really want people to start using crypto for more than speculation, right? We want to start using it for things like salaries, like subscriptions, like payments. And for this reason, if you're receiving your salary in streams, being able to stream into a savings account is very important. So this is something that I'm pretty sure we will start seeing some applications integrate natively this year. But in the meantime, we really want to see these bridges being built, right? So that's why we put this as one of the hackathon prizes. So it is possible to build a contract that will act as an intermediary and take these kind of constant streams, transform them into chunks, and deposit the chunks into the savings account. And for the user, the experience will be very similar, really. It's not a huge difference. And at the same time, they can basically stream into a savings account, right? Which is what they wanted. There is a small loss in APY because, while the money is in the intermediary contract, it's not gaining yield. But if you make that conversion often enough, it's not a really big deal. So it's still something that can be done.
Yeah. Basically, it's kind of like converting analog to digital signal, right?
Yeah, exactly. Exactly. Okay. I like the fact that you would define it like that. Wait, in this case, are we the analog or the digital though?
I would say you're the analog, right?
We're the analog, right? Yeah, because the digital is packetized. Yeah. Interesting.
Okay, thank you.
Harpal says Superfluid pulled together would be awesome. We agree. Our first super app was actually a streaming lottery. You can check it out in the examples repository. And if anybody wants to revive that and launch it, I think it would be awesome. It's not a no loss lottery. It's actually a loss lottery, a normal one, but it's a pretty fun example. Pat, your screen's gone black.
There we go.
Oh, here we go. All right. This is anybody else have any questions? We've already been going for an hour. I hope we've kind of cleared up a bit how this works in general, but if anybody has any specific questions, we're happy to hang along a bit. Yeah, the lottery, we really liked the lottery, but Meow was definitely the most excited person with the lottery. But yeah, if you want to revive it, I know a lot of people that would use it. There's a lot of gamblers in the crypto space, so you'll be fine finding users.
Gamblers? Nah, there's none of those here. This is all developers, hackers,
Yeah, lots of serious people, right?
philanthropists.
Yeah. Is anybody working on the streaming exchange? I don't think anybody mentioned it in this chat.
So what that is allowing you to trade tokens in a stream, right?
Yeah. Yeah, this could be it could be either buying Ether with a stream of USDC, or maybe swapping stable coins, for example, or it could be maybe selling a governance token over time, whatever kind of constitutes this crossing of one token and another. It would be cool if anybody was working on that. Maybe if you want to share how you're approaching that, that would be great. Okay, Harpal wants us to unlock houses with streams. We'll get there. We'll get there. Yeah, renting, basically renting. Yeah. I think ultimately, I mean, at Superfluid, we believe in the future, all our recurring payments will be done in streams, because it's actually a much better way of doing recurring payments, because you never have to wait. If you think about it, when you do a payment once a month, one of the parties is always waiting on the other party, right? And that's bad for business, because you don't know if they'll pay you or not. With streams, you always know. So I think in the future, we will be paying our rent like that, because our landlord wants to know if we stop paying, right? And as a landlord, I want to know if my tenant is not paying. So I think that will happen. I don't know if it will require digital locks, but that would be pretty neat, I think. All right. Must be nice to stream hiring bonuses, so to not pay in lump sums. Could see real HR applications with streaming. Yeah, I agree. I think salaries, even if it's not maybe 100% of the salary, but even just having a part of it that's always streamed, I think would be very, very, very good. We're starting to see this in traditional fintech as well. Although it's done through payday loans, but the concept is similar, right? People want to get their money as they earn it. They don't want to get it in a month. So I think it's definitely going to be part of the HR of the future. I think the main problem here is figuring out the accounting, but there's a lot of smart people that are trying to figure out the accounting side of crypto. So hopefully we'll be able to sort that problem.
It's just basic math, right? How hard could it be?
I don't think it's hard, but
it's a lot of work, though.
It's a lot of work.
Yeah.
For sure. Yeah, it's one transaction every few seconds. It's a lot to reconciliate. But in your super app, it's actually easier than outside of a super app, funnily enough. The super app always has a very precise notion of time, while outside of a blockchain, time is harder to use.
One thing I discovered while working on some time is in Solidity is not necessarily the same in Unix or the rest of the computing world. Like if you look at how many seconds are in a month, it's not what you would expect. Like if you just Google it. So, like the number of seconds in periods of time in Solidity is it's a little bit wonky, or it wasn't intuitive. It wasn't what I expected. So.
Okay, so Light is asking, if a new block is not added to the blockchain, will the stream stop? Well, if a new block isn't added to the blockchain, something really bad has happened. So yeah, the stream will stop, but I mean, I don't think Ethereum's ever stopped. So you probably don't have to worry about that. But yeah, we do depend on the block timestamp. So if a block is created that doesn't have the correct timestamp, for example, that could impact the streams. But consensus rules are quite clear on this. So it's very unlikely to happen. And ultimately, you can't steal that much money either. So it's very, very unlikely to happen. All right. Okay, everyone. Thanks a lot for joining. It was great to see a lot of new people in here. Are there any last questions? Otherwise, we can regroup maybe on Discord if anybody wants to share some code or ask us any kind of more detailed questions. Or I know Light, you were saying you're blocked, so feel free to ask us in Discord there. We can try and unblock you from your problems. And yeah, it's super exciting to see so many people hacking on Superfluid. Do let us know if there's anything we can do better. Patrick is the guy making the docs, so if anything is wrong there, if there's a typo, feel free to come and tell us and shame him publicly. But if they're good, also come and tell us, because I think they're not bad. Oh yeah, you're right. Light did find a typo actually. Yeah, he found a typo. All right. Okay. Thanks a lot, everyone. Cheers. See you at the next call and keep us updated on what you're building. So the Discord is the best place. I'll put the link in the chat. So if you're not already in that, you can join us. It's great, full of very helpful people, and we're always there to help you fix your problems. And I hope to see you all around it at Hack Money and see your apps go mainnet afterwards.